welcome everybody to Dave Cooper Live, where we showcase the people, the products, and the processes to help us all build it better. So today we ask, what does 10 years of research and development and a 30 million pound investment get you in terms of construction transformation? We'll learn how the product platform Robook, launched by the Construction Innovation Hub, actually works. Today, we are welcoming Richard Crosby, Director of Seismic Group. He'll share how the modern methods of construction platform allows for a single, seamless building process, even when 2D and 3D building components come from different manufacturers, from different regions. Hear about the incredible award-winning results on how Seismic is reducing time, cost, and carbon and smashing 2025 government targets. And the best part, they can help you as well. But first, we always have to say thank you to our sponsors. So make sure you say thank you to them. And here's a big shout out to them. Forward Solutions Group is successfully driving companies to succeed where others have failed. Are you looking to start a factory, optimize your existing factory, streamline your production, or take your team to the next level? Whatever your needs are, Forward has a solution for you. Reach out to Ben at forwardsolutionsgroup.com. Halleck Ltd. has a long history of innovation in cold form steel manufacturing and producing innovative precision roll forming technology for customers throughout the United States and the world. Check out their machine buyer's guide for off-site modular construction or fast build construction with light steel for framing. Go to their website, halleckltd.com. Brought to you by Greatech, one of the largest Autodesk partners globally and software developer of the PowerPack Advanced Design, Advanced Steel, and the StruxSoft product line. The complete solution to automate wood and light gauge steel framing, design, and documentation, all the way out to CNC output, model, design, and manufacture with StruxSoft. Learn more at StruxSoftSolutions.com. All right, again, listen, we can't bring you all of these informative conversations without our sponsors. So please take a moment after the show and go say thank you and take a look at what they have to offer as well. All right, let's get into it. We got Mr. Richard Crosby sitting in the background, but not for long. Let's welcome him to the show. Richard, thank you for joining us today.
Hello there, Dave.
Man, I am super excited. I know it's dinner time, wine, beer, cocktail hour over in England, but super excited to have you on the show. So thanks for staying up a little bit later tonight to work and joining us.
No problem at all. Thank you. A bit early for beer for me on a Monday night, but all good.
Good. Hey, listen, Richard, on this show, we ask everybody to start telling them about who they are, where they come from, what they do. In fact, we want to know everything about you from the moment you were born to this very moment in time. Do not leave out any of the good stuff from the hospital, because we will have your mother on the show, and I heard that could be quite a journey for you. But before we do that, you got a minute and a half, 2 minutes to give us all.
Hi, everybody. Richard Crosby here. Obsessed about productivity in the construction industry. Born and bred in Yorkshire, in the north of England, the heart of the industrial lands. So maybe that's something in the blood. Been working construction since I was 17 years old. Started life as a construction planner. Maybe that's also part of why I do what I do. I like to speed things up, make things more efficient. Moved into construction project management and at board level, a number of different organizations, client organizations, consultants, contractors. I've got a fairly broad spectrum of background in the construction industry. I love the construction industry. It is the best industry in the world, and we can make it better. That's what I'm all about, and that's what I love doing.
You know what? And I love that too. In fact, I'm going to try and give us some fireworks because this is a cool new feature. I love it. I love the construction industry as well. And I love the fact that you're putting your heart and soul into helping to change this industry. And you're putting, 10 years into it now, give or take, on building what you're building. not to mention all the time before. So let's hop into it. Seismic Group, right? Let's talk about what the Seismic platform does, and where did this come from, Richard? So when I think about this, like, talk to me about a little bit, like, were you sitting there drinking beers and you had this grand idea and, you're going to put all these moving parts that nobody's been able to put together before together? How did this happen?
It wasn't quite as quick as that. It started when I first started work back at 17 years old. I started learning as a planner and a scheduler at the time. And I just thought, why are we doing it like this? Why asking all these stupid questions, or appeared to be stupid questions at the time? And the more I got involved in it and stuck into it, I just thought, well, actually, why are we breaking all these little pieces into even smaller little pieces and then carrying them up into building up in the air? It just seemed a hugely inefficient process. What we were doing, and old contracts managers at the time I was dealing with always used to say to me, if you build faster, it'll be cheaper, as a rule of thumb. And I've always carried that with me for many, many years. So I've always been about that production speed.
If you build faster, it'll be cheaper. Is that what you said?
As a general rule, yes.
As a general rule. And to build faster, you decided we need to have some tools to be able to leverage offsite manufacturing regardless of the manufacturer.
Absolutely. And just construction generally is an inefficient process. We've evolved using the same process. We've got a whole ecosystem around us which is based on the same process, even though technology and changes has moved on, and we've not caught up with it. So we're just stuck in a bit of a rut of where we go. So we want to try to look at other industries of how they work, like the aerospace industry, and look at how aircraft are made. They make things in all sorts of different parts of the world, and then they bring them together all at the same time. So why can't we do that in construction?
Yeah, you know what? You're absolutely right. And let me ask you this, on your journey, and I know we're going to get into a presentation. You're going to walk us through the platform and everything that it does. But did you find that the technology already exists? You just had to go out and figure out how it works for our industry?
It's more of a philosophy that was already there that works within other industries that we could bring across. And it was about making sure how we get the industry to collaborate together better and work together for the better of the whole industry and moving production around. So yeah, it was in many ways. It's not a big technology problem. It's a cultural problem that I find, and we've got to try and shift that bit by bit.
A cultural problem. That's interesting. We're going to jump into that a little bit more in your presentation as we move forward. But I want everybody to know out there that there is a QR code right above Richard's head. If you want free access to the International Builders Show, go ahead and click that QR link. There is a chance of to win 28 tickets that are out there. And 3 of those tickets are the full access pass worth $875. That's a lot of gambling in Vegas you can do with $875 after the show. So make sure you click that link, fill out the form. We're going to be drawing the names over the next few weeks and have your lucky chance of winning. All right, Richard, here's something I wanted before we hop into this. Say, this is no longer theory. This is being used, and people are actually building with this platform. Is that correct?
We are indeed, yes. And the more people get on board and build with it, the more efficient it will be, and people will benefit more and more as they do it.
Got it. Got it. Why don't we hop into that presentation? I'll put it up on the screen here for you.
Okay. Everybody see that?
It's there.
No, Seismic Group. All starts with productivity. As Paul Krugman once said, productivity isn't everything, but it is almost in the long run. Hopefully I can get that message across to you in what we're doing here. So I'm going to tell you a little bit about me and what we're doing with the Seismic Group. What we do, a little bit about systems versus platforms, so you don't have to read 57 odd pages of the platform rulebook. A little bit about the Seismic platform, introduction to that and the benefits, and then we can fire off with the questions and answers. All started about 10 years ago, hence the 10-year lifespan of this, when I was asked to help the Department for Education develop some schools. They couldn't deliver their schools, particularly in the southeast of England, within their funding rates. There was all sorts of problems going on, so I was asked to broaden the market. I started looking at the volumetric industry of how we do that, to broaden the industry, and I thought, there's something quite interesting going on but the industry 10 years ago, it's testament to how that's moved on. But 10 years ago, it wasn't what it is now, put it that way. I developed, to try to cut a lot of risk out of the project, what was known as the component schools solution. It was a Lego brick of different component parts built to a volumetric grid that theoretically could be put together in numerous ways. But it was on the theory that if we can repeat processes, we can get efficiency out of the way. The idea of one whole company making all these variable different bits didn't seem particularly efficient to me, but a series of companies making more standardized components would be to get there. The problem we had is that every single volumetric company had a different system that they were touting as their best system. So I got 5 of the biggest volumetric companies at the time together, and I overlaid their systems and grids. And guess what? There was 100 millimeters difference and not a lot else.
That was it.
That was it. There was a couple of minor structural variants in it, but there was 100 mil difference in it because they were all working to the same constraints. And worse than that, they were going to the same supplier for the steel. So the idea of them bringing in a common frame that could all connect together and be delivered more efficiently came about. We then got some funding. The government got excited. I was presenting to the Government Construction Board at the time. They said, well, it wasn't quite as simple as that, but we managed to apply and get some funding to develop a connector block that would enable, taking the inspiration of the ISO fixing of the shipping container, we could lock things together from different suppliers to do that. And better than that, we could deliver these things in a more efficient manufacturing process. So we could take the process of 2D construction and assemble them into 3D at any point in the process, either at the end of the production line or on site. Think about that. That really breaks the mold in terms of what's been done before.
So my first question is this: how did you get 5 different companies to share all of their data with you to help you do this solution? Because I think that by itself is a big undertaking. At least it would be here in the States, because everybody has the greatest idea here.
With the opportunity of We'll Grow the Market, and I was working with the Department for Education. They were promising 400 schools a year, and I was saying, well, you've got to grow. You've got to be more productive to take on this bigger workload. So right. I managed to the chief execs of each of these companies, bring them around the table. It was the first time they'd ever met, and we brought them around the table together, ever in the history of their companies. And we said to them, look, if we can get this as a common way of working, we can grow the whole business, the whole part of this, and we can deliver more efficiently. Most of them agreed, not all of them, but most of them agreed. And the ones that we got to agree then came part of this collaboration, and government helped funding them to develop them.
So with this, Richard, wood, steel, concrete. I mean, I know you mentioned steel, and they were all buying from the same steel manufacturer. But when we think about this, wood, steel, concrete, hemp, straw, what types of structural materials can this platform actually be applied to? Is it limitless, or is it just for certain types of manufacturing?
Technically, it's limitless, but some are more effective than others. So we've used steel. Because of the tolerances, we could get much tighter tolerances. Yeah. And that allowed us to make other components that could just slot in position. You can use timber, or glue-lam type timber structures, but we've found that we can't get as tight tolerances there. So other materials that work with that have to be then crafted around it, and you get waste. So the tighter tolerances, the better for joining things together. Anybody that's together some flat pack furniture will understand the importance of tolerances when joining things together in that way.
Got it. All right, let's keep rocking and rolling on this here.
So that was a huge big success, but it wasn't the platform. It was just a base frame system at the time. So we got, because of the success of that, government then gave us some more funding, further still, and wider people involved. We brought in people like Tata Steel and others, not just the Manufacturing Technology Centre, the Active Building Centre, to look at carbon, and various other organisations. And we said, right, we need to prototype it. We need to develop the envelope in different component forms that can be adjustable and fit and swap and interchange to the frames and the cassettes. And we want to prototype it. And we want to, more importantly, we want to prototype the theory of having 3 different manufacturers in 3 different parts of the country, or even different countries if you class, and what we did. Make those in parallel with each other, off-site, and then come together and all fit together. So we had Tata Steel making all the roof cassette elements. We had Algeco making the first floor components in North Yorkshire. Tata were making their roof components in Wales, and we had McAvoy Group making the ground floor areas over in Northern Ireland. So 3 different regions, and which was mirroring how aircraft are built. If you want to build an aircraft, you tend to have engines made in one country, wings in another, shipped over to wherever they're going to be made, put together, and then flown off. So it was that principle, but we can cut the critical path into as many pieces as we've got components to speed it up.
So let me ask you, I think companies like Tata, they actually have innovation centers where they've been researching offsite construction. Is that accurate? So they were probably very willing to collaborate with you in these different companies to come up with better solutions.
They were very, very willing, particularly because we were using steel frame. But absolutely, they were a very important partner with it, and they provided all the cladding on the demonstrator building for us as well. Sure. So yeah, very important partner in it.
And before we move forward, I just got another question. Are all 5 of these companies that you started with still working together and collaborating to keep building out the system?
Not entirely. There's a bit of a fragmentation happened, but we are looking at a couple of schemes at the moment where hopefully we can bring those together and bring new ones in as well to bring it forward. Absolutely.
Excellent.
So once we've proven that, yes, and it shows warts and all, what it does and what it doesn't do, and where the issues were. But that's the whole point of a prototype. And because it was government funded, we were keen to show the rest of the industry what we were doing and how we were doing it, so people would learn. On the back of that, we won various awards in terms of how we do that. So we thought, well, how do we make this and put this out for the whole industry to start to use it? So that's what we started up, and we changed our business model from what I was doing before, and we set up Seismic Group purely with the purpose of licensing out the information, the patent information that we got, because the connector block is patented. It's unique in that it can use a 2D and a 3D system together in the same way. So you can produce cassettes and then assemble them in different ways. And it's not, and it was important that it's not owned by one organization in the game, in construction, competing with somebody else. We're not competing with anybody. So we just allow people to bring them together to make things bigger projects and bigger volumes through. And that's what we do. What's the next bit? Yeah. So that's exactly what we do. We license it out. We standardize the components with people. We develop it. We haven't got every single component to build everything. But part of the model is in licensing it out, because we license it out for cost. We get information back to those that we license it, and we develop the next components progressively, so that we're always learning. So one thing we don't do in construction generally is learn. We always start from a blank piece of paper, whereas what we're trying to do is move it on each time, so it's been done before, and pass that learning on. Buildings tend to be rooms either side of a corridor. They're not always that different. So we use the commonality that already exists. And we can apply that. We can apply that across lots of different sectors: mixed use, education, healthcare, leisure, and residential. We're doing quite a bit in residential actually at the moment, or accommodation type. That seems to be the big demand. It all started, we got the funding because of the drivers through the Construction 2025 targets, the playbooks off the back of it, and the rule book. We meet every single requirement of the playbook, all 8 requirements. The key one is being open to market. There's not many people that can achieve that, because why would you spend all that money on R&D and then just give it away to everybody else? We do that.
I'm going to have to ask you why.
Because that's how a platform works. There's no point having a platform. Facebook will be rubbish if there was only 2 people using it. So the fact everybody can use it, the better. So the more people that use it, the better. So we do mark up to the patented components by a small amount to do that, but it only really works if we get lots and lots working.
I think that's a very important point, right? Because I don't think a lot of people would understand it, but when you put it in that context of what a platform is, like a Facebook or a LinkedIn or any of the other stuff, now it makes sense.
And this is how I try and articulate it as simple as I can. The difference between a platform and a system is that systems are owned and controlled by one organization that's delivering everything. So you have to go to that organization. That's the system. A platform is different. It's like Uber or whatever. You can use lots of them all come together to do it. We just facilitate it in that way. So we become a platform provider so that we can use any supplier and any series of components. It's unrestricted. And that allows traditional supply chains to get involved as well. It's not volumetric, it's 2D, it's 3D, it's traditional. It's a series of components that you can use through existing supply chains.
Got it.
Systems tend to be expensive, risky, and slow because one organization is controlling everything. In current economic climates, if somebody goes bust, you're in trouble if you've designed everything around one system as a client. So they can be very risky. We've seen a different change of structure happening over the years. We've been involved in this. So the traditional modern methods of industrialized construction process is where you'd have a general contractor, a tier 1 contractor, and they might have some element of specialist MMC involvement, industrialized involvement, whether that be bathroom pods or things like that. But it tends to be relatively pockets of it in the scheme of things. Volumetrics always struggled with that because it's a high volume in there. So they've tried to move into that space of being that tier 1 provider with mixed success. Some do a fantastic job, others less so to do that. And it's tarnished the market in some ways, and some not performing that well. With a platform, you can use either, depending on what you're using. You can use it as a volumetric, you use it as or a 2D, or even a bag of bits if you want. And we're seeing a lot of interest in the tier 1 general contractors wanting to adopt this now because they can control the structure.
Yeah, how many users do you currently have using the platform?
We've got 4 different end user clients. We've got 5 tier 1 contractors using it, and we've got a number of suppliers on there as well.
Great.
Try to show this a little bit more easier. Is it generally with the volumetric approach? It tends to be done one big sort of warehouse factory produces them, and you cart them to site. With seismic, you can have 2 or 3 or as many as you want to do that, as I've described with our other way of doing it. Or you can just use one and knowing full well you can go to somewhere else if there's a problem further down the line. But we've actually got one client who's really embracing this and full on, and he's breaking this down into cassettes and service pods and wall panels. So each part he's got different supply chains out. So it almost replicates a traditional set, but instead of having lots of trades, we have lots of components. So he can manage his risk in that way a little more effectively. And in theory, you don't really need a permanent factory necessarily. You can use pop-ups to do that because you're making all the envelope elements through the supply chain already and then assembling them. So that's the basics of how it all operates and comes together. But what we do is we leverage the supply chain and the scalability on all this. So we think we're getting all the best forms of construction in one place. That there's nothing faster on site than volumetric delivery, but it's not so fast in the factory. It slows it down. So 2D is faster in the factory. So we can do the 2D element there, but we can use the traditional supply chain risk management model of having lots of components and control of the supply chain. So the best parts of all that. It works in exactly the same way, warranty-wise, as traditional construction. It's the same solution. We don't take design responsibility. We just de-risk it for the market and then they adapt it to suit. And because of that, there's no need for real specialist contractors and specialist consultants, which again de-risks it. We don't have any special materials. Everything in the world of this forms of construction start thinking that we're using some sort of fancy weird materials. We're not. We all use steel, concrete, and timber, really, don't we? Whatever we do, and so that's what we use. It's nothing different. It just goes together in a different sequence. Difference, though, is this is proven and it's tested. We don't test traditional construction because everything is a bit of a one-off, so nothing gets tested. We rely on design liability insurances and things like that from the architects and things like that. That still happens, but we can de-risk it because we've tested it, and we've tested it under load. We've burnt the thing. We've vibrated it to death. So we've tested it for acoustics, vibration, fire, you name it. We've tested it. We're not aware of anything that's been tested to this level.
So Richard, talk me through real quick so I understand. I'm trying to put my head around this. So we're in a platform. So we're kind of in the cloud of the community. I work for a design manufacturer or whatever in the offsite space. All of my products are within this platform already. So as a designer, engineer, or structural, am I pulling from the platform all these kits of parts to build my structure, and they just all work together magically because of the code, or how does it work?
Well, it's platforms. There's a series of details. We have optimum dimension sizes, but they can be varied to suit. So we can get the most efficient way of doing it. It can be built in the most efficient way for that particular site. We can use in construction, everything's different anyway. So most of the suppliers in the market are used to doing things bespoke. So once they start doing things at bigger volumes progressively and standardize it, they can start to see efficiencies in the process themselves, and they come on board and they build it up, and then they get their supply chain on board, and it starts to get faster and faster and faster and more efficient as we go.
Excellent.
This is pretty much where we are. It all starts with this patented connector block that we have, which is the crucial part of it. It's not a massively technical piece of technology. It's really simple, but it's what it does that's the interesting piece. That starts with everything. Then we have cold rolled sections that come out within the frames that can be bought through general steel fabricators. But then we have a hot rolled post to take additional weight, cold rolled sections. And they go then to form up floor, ceiling, and wall cassettes that can have variable build-ups, variable dimensions. So everything's movable and variable, but we have optimums. So it's a bit like choosing a kitchen. You have an optimum dimension for the kitchen, how that works, and you can always that bespoke bit at the end if you suit it where it suits. So that's what we do. We use that connector that provides all the interoperability. We can modify the components to suit whatever's needed to do it. We can add new ones in, so you can mix and match the 2D with the 3D with the traditional construction to suit your project and your needs. Everything's designed around constraints, the constraints of the project, and the constraints of the site, and the constraints of the brief to get the optimum. So it takes a lot of the difficult decision making out of it.
Yeah, for sure.
And these were quite scary results at the end of it. We had it independently assessed in terms of value, speed, and carbon. We were only looking at trying to get the cost out of this and by making it more efficient. Nobody's ever going to say what they really do, because every project's very different. But with all the difference in value, we can prove we can do better value. 75%. Well, actually, we could do more if you had more suppliers involved. But how brave do you want to be?
Right. Well, I mean, you have here, and then I'm going to get back to some of the rest of your portfolio or slides there. But you got 75% improvement in speed efficiency here. You have a 70% reduction in carbon, is what you're looking at. And then you got 47% improvement in value when it comes to design, production, and construction, health and safety, and performance, traceability, waste. Yeah, ton. People, longevity. And that's some of the stuff we were just talking about, right? As the platform grows, as the participants grow, as the suppliers grow, all of this grows together. And I think that's super important. But one thing I have is how does MEPs work in your platform, right? Because I see the bones of the structure. How does the MEP side of this work?
So we focused on the envelope first, the structure in the envelope, first of
Yeah.
all. And what it does do, we do work with, and we have a number of suppliers that we act as sort of use as peripheral components to that. Because we're going so fast with this, it changes the critical path in a fair bit. So your internal fit out, including the MEP, needs to change. So we need to be moving into more a push fit type position that can be coordinated amongst components. So that's crucial. But it does need, we need to speed this up. So it tends to, so what we're using systems that are push fit, so or kettle type connection fittings for electrical. So it takes the trade away, basically.
Got it. So I want to jump back over to this because I had a question come through. So they were saying, 75% improvement on speed efficiency, 70% reduction in carbon. The percentage numbers, where do they come from? 75% of what? What's the mark there?
We had loads and loads of data on schools because that's where the problem started originally to do that. So we had lots of that. So we compared that against traditional built schools in that way. So the speed element in particular, all you need to do is just bring in another supplier and you chopped it down even further. The carbon's it was a bit of a scale because we didn't focus on carbon originally trying to do this. It was purely trying to get the cost down and the production speed down. Then the Swansea University did analysis over that, and they when they looked at it, when we're talking about whole life carbon, because what it did show is that people choose how they want to measure carbon to get the figures that they want, the solution. We use steel, timber, and concrete. What's the mix and match, and how you do that? So we looked at whole life and the end of life. And if you've got a number of different people that all can use the same bit, you can reuse more and more elements of it. So there's less going to landfill. And that's the simplest explanation I can give on this without boring everybody to death of how we get that carbon down. But it was independently assessed.
Right. Well, you got a great accent, so you're not boring me. I think it comes across just fine. I do want to go back, to this connector piece that you were talking about right here on this slide as well. It seems like this is kind of the magic wand. Could component manufacturers incorporate this connector as well to take their component businesses, towards a true building system, I guess?
Yeah, comes with a pack, basically. That's the key part of it. It's the node that joins it all together. It's the little dots on top of a Lego. It's the crucial part of it and where it still stands. So yes, exactly. It's the key part of it. We've got actually, it's been shown as a demonstration by the Manufacturing Technology Centre that you can have steel coming in at one end and the glue line beam coming out the other. So you can mix them with timber. You just change the bracket.
So just change the brackets. Right. So the connector is the key to all of this. And here's what I love, because a great quote comes up from my late friend, Jerry McCahey, where he does say that it's only a solution if it's a system. And that's kind of what you're saying is your system has the ability to not only work with steel, it can work with mass timber, CLT, pretty much anything that's a functional and dimensional material is what it sounds like.
Yeah, absolutely. And because part of the big problem with construction is fragmented. So every time we talk about 2D or 3D, we're fragmenting things a bit more. If we can have something that works across materials, across delivery methods of suppliers, then we're bringing it together, and that's what increases the efficiency and productivity of everybody together.
Got it. I'm going to put this back on the screen so you can finish. I don't know if we were done with the presentation or not, but let's put it up here.
We're done now.
We got through it all. There it is. And then that's some of the group there at the Seismic Group. I love it. All right. So we're going to get to a couple comments here in just a few, but, I have some things, right? So, I think I already know the answer to this, but is it cheaper to build this way? And I know what you're going to say once all the players and all the system starts going. But, can you explain the value versus the cost when it comes, the time, We had Trudy on the show, Trudy Solly, who I'm sure you know very well. And she talked about this a little bit, but what is the value versus the cost? And is this going to be the cheaper way to build, or the less expensive or more affordable, whatever word? Maybe cheaper is not the right word.
It is. Nobody's ever going to offer anything below market value, ultimately. But where this does start off with is that we can get it cheaper by building it in different methods to suit the location factors. We can build faster, significantly faster, so the return on investment for those engaging it is much faster. The cost of finance has gone through the roof, the cost of money has gone through the roof, so building faster makes it cheaper that way. And then, of course, there's that aggregation, demand and efficiency that will come gradually over time and get better. So that's what the value stuff all comes off. It's just part of it. It's the carbon. It falls off the back of productivity. If we aim for productivity, all the other stuff comes in. As I said at the presentation, productivity isn't everything, but it is almost.
It is almost everything. I love it. Regulations. They're burying us alive in regulations here in the United States, right? So, did you guys run into any regulatory environments that prevent, people from adopting your system, using this? And why I say that, right? Because you have different building components coming from different manufacturers. At any point, did you run into any hurdles with the government and the regulatory environment?
Not yet, only because we've tested it and we're comparing against traditional construction. Traditional construction comes from different manufacturers all over the world in lots of different pieces, so it's no different. And traditional construction is never been done before. It's relying on PI of we've tested it and we've got that certification to show it's been tested, so it's no different. And that's the beauty of this. It isn't any different to what everybody's using. We're just assembling it, or we have the option to assemble it in a more efficient way.
So, Richard, here I am. I'm a big general contractor or a manufacturer, and I say, all right, I'm watching this Dave Cooper live character guy here, and I'm interested in this product. How do I get involved? How do I adopt a system like this? Can I adopt a system like this? How does it work for me? What would you tell me if I called you and said, I like this, I think it's cool. I got this big jumbled mess of a manufacturing facility. Is this something you can help me put into my manufacturing, and how would that work? And then what is the cost for me to license it, like you were saying?
Well, what we do at the moment is ultimately, I'd like to make the license free, completely open source. So what we do is to start off with, to make sure people aren't just kicking tires and they're interested, is we license it out for cost against an original project. So if you've got a project that you want to use it on, or you think it might be useful, speak to us about it and we can quote you for that, but it will be at cost. It will be legal cost plus some administration and overhead. That's it. We provide consultancy services showing people how to use it, but the idea is that we show people's teams how to use it. It's not brain surgery. We'll soon pick it up, and then we have a small markup on the connector block through the supply chain further down the line. But it's pennies. But that's the whole point of making that volume, so we can make our money through further down the supply chain, so we can make it cheap as possible for the point of use.
Got it. So the connector point and all of this is something that comes in after I start using the platform, or do I need that connector piece in the beginning? Do I have to incorporate that connector into the way I already build?
You'll need to copy it into the design to do that, to start off with, to do that. But there'll be no cost to that until it's further down the line. It's a hidden cost within the supply chain. Yeah, these things are equivalent of £100 each. It's not big money in the scheme of things.
Got it. Have material passports for reuse of components been developed?
We're working on asset tagging things at the moment, so that's the plan. Not at the moment. It's not that part of it's not market ready yet, but that's the plan. We have to, through the patent requirements, we have to individually mark these things, so it should be fairly easy to add that on. That's what we're looking at doing.
Right. So, you know, and excuse me, because I was reading something that came through and I loved it, but that was a question from Ben Townsend, who's not showing up for some reason on here, and it came through on the backside of my platform. So thank you for that question, Ben. I didn't mean to jump the gun on you there. Where are people using this? Is this just in England, the UK, Europe? Can I use it here in the United States if I'm interested?
We're just using it in the UK at the moment, but we have got an international patents on this, and we would like to start to bring it across to other countries, including the USA. Don't know the market that well or what regulation requirements it would need to achieve yet, so we'd have to get through that hurdles. But I'm guessing you guys have got the same laws of physics that we have here, so I don't see why it wouldn't work.
Yeah, well, I mean, our regulation might be a little bit different. Your government's at least adopting modern methods of construction and really pushing forward to see change in how we build. You know, we're still trying to find our way through that whole mess. But of course, it's a much bigger country too. You know, as far as rules, regulations, and states. So I love it. I think this is awesome. So, how full is your pipeline?
Well, we can always be more full. That's it is. We are slowly getting there. It's been a slow start because people are wary of it. They don't believe the numbers until we start getting into it. Generally, people want to start to use their own, so we help them develop their own platform. Then they realize how expensive it is and the barriers that are involved. So they then move on to on ours. We're working. We've got. Residentials, as I mentioned before, is where everything's happening at the moment in terms of social residential, as Ben Townsend will know. To do that and other accommodation type thing within the government. The government have been pushing this in the UK quite hard. Just want to be focusing on the UK because that's had that government push. So we've got a number of new things that are a bit confidential at the moment, but are coming. Hopefully, will be announced in the coming weeks or so. They're quite big scale stuff, and that hopefully the whole industry can then jump on the back of and see the benefit of.
Well, you make sure you come here and tell us that, right? Let me give you some fireworks. I'm loving this. Look at that. That AI stuff is cool. Anyhow, I think that's great. Make sure when that does come out, reach out to us. I'd love to talk about what they're doing on the show. I think our audience would like to hear it as well. All right, one more question, then I'm going to go to some of the comments here. Who else is doing this type of work? Maybe you don't want to say your competitors out there, but is there a lot of competition out there? Has anybody else, been riding your coattails on this, or do you kind of see yourselves in the lead?
Everybody's been a lot of people trying to develop what they call platform solutions, but for some of the reasons that I've tried to articulate before, it's incredibly difficult and incredibly expensive. You guys have had companies like Brydenwood on there, who are perhaps other guys leading it. They've got the other platform within the rule book. There's a seismic one, the Brydenwood one, to do that. So they do some cool stuff.
Yeah. I love Jamie and those guys over at Brydenwood. They're super smart. They're fun to hang out with, and he won an award last year at Advancing Prefab, which I keep telling him congratulations. But I'm going to win this year, I think. Maybe. Nobody ever votes for me. Anywho, all right, let's get to some comments here. Second question, and I don't know why, Ben, your stuff isn't showing up. Ben Townsend. Have any schemes to date done flying factory assembly and fit out close to or on site?
That's a really interesting one. We've got one particular client who is actually buying the modules in 2D form and fitting them out in a temporary structure next to the site, and then craning them up into position so that he can cut down on his material transportation to the sort of second, third, fourth floors to do that. So he's taking it on from that view. So everybody can use it in a different way, but it depends on the nature of the site and the constraints of their site and how ambitious that particular contractor wants to be. You can start off with just using, one volumetric guy if you really want, knowing full well if there's a problem, you can go somewhere else at one level. At the other level, you can build it all in 2D form on site if you so wish. The key to that is, and come back to a point you made before about cost.
Yeah.
We can We play to the. It costs different amounts to build the same thing in different parts of the country. We have these location factors around the country. So London's, for obvious reasons, is more expensive to build than where I am now in Yorkshire. So you can assemble this with the same system in 2D and 3D form to where the labour is. So you can avoid transporting people as well as material and save on transport costs. So it depends on the nature of the site. There's no one right way to do it. It's just the most efficient way to suit that site and the constraints of that site.
Well, I love it when we get great questions. Ben, thank you so much for asking that question as well. All right, let's get to some comments here. Osama Ulabi, I love it. World of Smart Homes, Switzerland, Germany, Italy. We were on a tour with all of these folks this past year in Europe, and I have to tell you, they're coming up with some great processes and platforms as well, climatic ceilings. I mean, they're doing all kinds of cool stuff. So, Osama, it's good to see you. Tell Pernilla I said hello as well. Hope you guys are doing great over there. Look forward to telling that story more as you guys grow and progress as well. All right, we got the Greg Ugaldi in the house. Richard, at what point in the process is your preferred entry point into a project? And he says, great job, DC Live.
Well, I don't mind either way, but the most efficient way is from concept stage. So understand the constraints of the project in terms of the client and the site, and therefore we can absolutely max out the delivery method to do that. So concept stage is the preferred.
Greg, thanks for joining us today. Love it, love it. Osama had a follow-up. He said, maybe Richard could share the presentation online. Well, I can tell you where it does live, Osama. It lives on this YouTube channel right here now. You can go watch it over and over and over and over again. But yeah, Richard, if you wanted to put a link to the presentation, if that's something you wanted to let people download or look at, we can put that on our YouTube channel right here, and they can download it in the comments sections. It's not there yet, but we could put it there if Richard wants to do that.
Yeah, we can do that. No problem at all.
All right, perfect. So we'll put a link there and add that. All right, Doug Hayden. How you doing, Douglas? Good to see you. Yet another fantastic feature of future forward-facing company. Say that 3 times fast. Your podcast educates, save me time getting to know all of the players in prefab and help the industry move forward. Can't wait to see you at IBS in Vegas. Well, Douglas, thank you so much. That's really cool. I love when we hear comments like that. And just so everybody knows, up there in that corner over there, go ahead, hit that QR code. You want a chance to win an $875 ticket? All the education at the International Builder Show in Las Vegas coming up at the end of the month. Well, now's your chance. I have 28 tickets to give away, and 3 of those have the full education passes. So check it out. It's in the links below. Jen's putting it across the board there. That's right, February 27th through the 29th. Thank you, Doug, for commenting. Doug had another follow-up here. Does the seismic platform talk to Revit? That's a great question.
Yes, it does.
That's a simple, straight up answer too. Is there any platforms it doesn't talk to?
We issue it out in split it up in IFC form so it can work to most of the common systems that are out there at the moment.
Right. Perfect. Well, tell me, is there anything that I did not talk about, Richard, that you want to make sure people know before we wrap this up today?
I don't think so. You caught me on the hoof there. I think we managed to get most of the things across, but I'm sure people will bombard me with questions or you with questions or whatever if we have missed something out between us.
So I know people can reach out to you on LinkedIn. Also, there is the website, and on the website you have the contact us page. I'm assuming that's the best way to get a hold of you guys, huh?
Indeed, absolutely.
Awesome. All right. So if you're not following Richard and you're not following the Seismic Group, well, you should go there and follow his page after you subscribe to our YouTube channel and our LinkedIn page and everything else. Sorry, Richard, don't mean to make you come in second on this one, but we need people to help us grow this channel and have some fun. We're looking forward to a fabulous 2024 this year, having a great time with it. Richard, thank you so much for joining us today.
You're very welcome. Thank you.
And for the rest of you out there, it's Monday. We got 4.5 more days to build it better. And we're going to be bringing you more people this Wednesday. That's right. Windover Construction. Stuart, the CEO himself, right here on Dave Cooper Live. Wait until you hear some of these stories. They were testing the robotic construction animal from Boston Robotics, and the darn thing walked right off the building floor and down a couple stories. We're going to have all kinds of great conversations on the show with Windover Construction. They are leading the way in construction technology. They test everything out on their job sites, and they are world-renowned leaders in how to use BIM software with some of his other team members like Amir. So with that said, you want to tune in Wednesday, 1 p.m. Eastern on Dave Cooper Live. And with that said, here's some more sponsors. Make sure you thank them. And Richard, you stay right there. I'll come back to you after the end of the show. Thanks, everybody. Happy Monday. What an amazing show. Thank you to all of our sponsors for helping us to continue to bring all of these innovative conversations to all of you out there. Please visit them, see what they have to offer you. And as always, subscribe to the YouTube channel and ring that bell. It would mean the world to us. I'm Dave Cooper. Thanks for watching.